Okay, so in this video we're going to skip ahead to section 5.1 and look a little bit more about how to apply this idea of finding the area under a curve or the area between two curves. So we're going to talk about in this video is something called consumer and producer surplus. So here we have a function d of x equals x minus 6 quantity squared, which at x equals 0 is at 36. And the x-axis is the number of units that is demanded, and the y-axis is the price. Okay, and we can say that d of x is what's called the demand curve. Okay, so what it is the price a consumer is willing to pay for x units. Okay, and so in general, the price that the consumer is willing to pay is going to go down as a consumer is going to buy more units. So let's say that we have a certain number of units down here, and the consumer buys 2 units. So we'll say this is x is equal to 2. Okay, well, if the consumer was willing to pay this much here for less than 2 units, and they're paying this much here for the first 2 units, then we can say that they get some extra value from this region right here. Okay, so this down here is the amount that they spend. All right, and this up here is the extra value that they get, which we call the extra utility. All right, and this has a name. This here is what's called the consumer surplus. So it's the extra utility that the consumer gets for buying more units, essentially. Since they bought 2 units and we're going to buy it at this price right here, then they got some extra value out of the first 2 units. So if you want to figure out what this thing is called a consumer surplus, then you can use an integral formula like we've been looking at, and we can go, if 2 is what we're going to call Q, which is a number of units, then we'll go from 0 to Q of d of x dx minus Q times P, where in this case P is a price that they're actually paying. So this here is going to be the area of the rectangle. All right, and this here is what's called the consumer expenditure. All right, because in this case, this area right here is just going to be the bottom length, which is Q, times the vertical length, which is P, so that's Q times P. And this here is going to be, like we've said before, if we have d of x and we're integrating it from 0 to Q, this is going to be the area under the demand curve. Okay, so this here is the important formula that you need to know for consumer surplus. So if you have a certain function for your demand function, in this case we have x minus 6 squared, then if we want to find the consumer surplus, what we're going to do is we're going to take the integral from 0 to 2 of d of x, which in this case is x minus 6 squared dx, and then we're going to subtract off Q times P, and P in this case is equal to 2 minus 6 quantity squared, which is 16. So we're going to take Q times P, Q is 2, and P is 16. All right, and then we're going to solve for this. So if we wanted to find the integral of this right here, what we could do is we could expand it out, and we could do the integral from 0 to 2 of this and evaluate it at 2 or 0. Or we could just do this in our calculator using the fn int function. All right, and if we do that, what we're going to end up getting is that this is 50.67 minus 32, which is 18.67. Okay, and that here is what we're going to call the consumer surplus. Okay, so this is going to be one calculation we're going to do. We're going to also see that there's another curve that turns. Okay, so we can also think about this from the standpoint of a producer who is making a certain number of units and willing to accept a certain price for those units. So here we have a function. Before we had d of x, here we have s of x, and s of x is what's called the supply function. All right, and this is the price a producer is willing to accept for x units. Okay, so in this case, s of x is increasing, and here we have x is the number of units. So let's say that the producer produces 1, 2, 3, 4 units and is willing to accept this price for those units. Well, in this case, what we have is we have a certain amount of extra up here, money essentially, that the producer gets, that it was more than it was willing to accept. So it was willing to accept this price for this number of units, but it sold this number of units and got this price. So all of this extra in here is extra money that the producer gets that is above what it was willing to accept for these units. So in this case, what we have is we have the extra. This is what's called a producer surplus. All right. And the producer surplus is going to be the extra money is the extra money the producer receives above what it was willing to accept. Okay, so it was willing to accept this price again for the number of units before, in this case, a 1, 2, 3, 4th unit, but it ended up getting this much for all of the units, which we'll call P, again, and we'll call this Q. And so if we want to calculate the producer surplus, what we're going to do is take the area of this rectangle right here, and then we're going to subtract off this area right here in order to get this leftover region that's shaded. So in this case, we'll say that the producer surplus is going to be Q times P minus the integral from 0 to Q of S of X dx. All right, and this right here is what's called the total receipts. All right, and this here is the area under the supply curve. Okay, so again, if we want to look at an example of this, what we could do is say that S of X is equal to 1/3 x squared plus x plus 3. All right, and we want to find the producer surplus when x equals 2. All right, so if we have something like this for our supply curve, then it's going to look something like this. All right, and if we have 2 sketch pads, so that's 1, 2, then we're going to end up getting that the P in this case is going to be S of 2, because this is 2, and that's equal to 1/3 times 2 squared plus 2 plus 3, which is 5 plus 4/3, which is $6.33. Okay, and this is per unit. All right, so then if we know that, then we can say that the producer surplus is equal to Q times P minus the integral from 0 to Q of S of X dx. And in this case, that's going to be Q is going to be 2, because we're looking for X equals 2. And the price we said is 6.33, and this is dollars per unit, dollars up here. And then this is minus the integral from 0 to 2 of 1/3 x squared plus x plus 3, and that's a dx. All right. And so what we end up getting is this first term here is $12.66. All right. And then the second term, again, we can do this using the fn int function. All right, and if we do that, that ends up giving us 8 8/9. So this is going to end up being $8.89. All right, and if we do that, 1266 minus 889, this gives us $3.77. All right, so this here is the producer surplus.